why we say that for all of us, these new approaches to cost reduction represent an exciting opportunity. Just as important as reducing direct costs is reducing indirect costs. By itself, this presentation you'll hear next is provocative. In combination with value control, it becomes even more so. To begin the discussion of how to get better handles on indirect costs, here's Mr. J.P. Thibodeau. Phil?
Thank you. For years, we have been searching for better tools to help us understand indirect costs. Indirect costs which make up more than half our company's sales dollar. Today, we will describe an approach which will give better insight into indirect costs, what really causes them, and what the impact of a single decision can be on people and on costs downstream. The program is a joint venture of engineering, manufacturing, and accounting services. Its purpose is to prevent or control indirect costs by helping people make better day-to-day decisions. The approach has been tried in several departments, and every indication is that there is something important here for every department in the company. To begin with, our approach to gaining insight into indirect costs requires that we find out what indirect activities in a business are created by such things as a new model introduction, or a design decision, or the initiation of a requisition. What really happens when a requisition enters the factory? What activities start to work? Drafting, ordering, planning, purchasing, and what others? This step is not a theoretical one. In the departments where we have been working, information of this type has been developed by going down into the guts of the business and finding out what really goes on from the people who are actually doing the work. The second step is to identify the key parameter which governs the effort required in each activity, or which may be the best indicator of the workload in that activity. For example, if the activity is purchasing, then the best indicator might be the number of purchase orders placed. The next step is to determine the volume or quantity of each parameter for a one-year period, for instance, the number of purchase orders. Next, the yearly costs of each activity are estimated, and the costs are expressed as a per-unit index, for instance, $6 per purchase order. This five-step process yields a cost index for each activity. More important, it provides tangible data that can be used to explore the real effects decisions have on indirect effort and on indirect costs. This is where the valuable insight comes from, not from formally issued reports by themselves, but from asking test questions to find out what action takes place when a decision is made. The first five steps result in a table of costs, volumes, and cost indices for each activity. Typically, we will have 50 activities like the few shown here, ordering, purchasing, and so on. A couple of comments on cost indices in particular. First, they necessarily involve estimates and judgments. For instance, how much relative effort is required to order an item for the first time as against repeating something done before? We chose to make a judgment. The average cost of ordering a new parts list item is 60 cents, compared with 30 cents for an old one. We know intuitively that some things require more effort than others, but we generally have not put quantitative judgments on these. A second point about the indices. They are not incremental costs. Eliminating a single purchase order does not save $6.30. What they do represent is the tendency towards cost caused by a pattern of decisions. So far, what I've summarized for you is a cost analysis job. The real value of the approach is in the next step. That is, exploring the impact of day-to-day decisions on indirect costs. Charlie Fontaine will show you how the cost table data can be applied and identify opportunities that are disclosed by such a look. Charlie?
A decision is like a snowball. By the time it reaches the bottom of your organization, it involves hundreds of people, not in just one spot or in one function, but in every nook and cranny of the business. Let's look at some examples of decisions that create indirect costs. And for the moment, we'll stick to a requisition type business. For instance, an engineer specifies a new drawing instead of an old one. He probably has a good feel for the direct costs, labor and material involved, but what is the indirect cost? Well, if we assume we're talking about a drawing with 6 part list items to be made in the factory, the new drawing costs roughly 4 times as much as the old. And it's not unusual to find where 6 new drawings are issued when 1 would do. Let's see how we arrived at these totals. First, we listed the activities influenced by this decision and the parameters from the cost table Phil has described and the cost index figures for each activity. We know that the drawing creates with it the demand for prints, ordering, manufacturing planning, and so forth. Now we know 2 things more. The numbers are large and the differences are significant. Availability of this kind of quantitative data might very well have influenced the engineer in his decision, or it might have resulted in a policy to guide him. Basically, this is a method for testing any question involving indirect efforts. Take another case. For years, people have wondered what product complexity costs. Here's an example of what happens to indirect costs. If we consider the greater number of drawings, operations, vouchers, and so forth, all involved in making 3 pieces instead of 1, then 4 times as much indirect effort is created. A simple engineering change notice involving 3 items costed out to nearly $300 of indirect effort. One department had 1,300 emergency instructions a year caused by errors, false starts, customer changes, and so forth. Even at the $300 rate for simple changes, this represents nearly $500,000. One strong impression from our experience is the extent to which indirect costs mount with every change. We wish that just once, every person in your business could get a first-hand look at the work created when an unplanned change hits the factory floor. The examples so far deal with design decisions, but the approach yields insight across the whole business. Initiating a labor voucher, for instance, triggers efforts in wage rate, in planning, and data processing, in dispatching, and in other areas. In a case we studied, the cost on a per voucher base was $1.04, which was 15% of the direct labor the voucher defined. Of course, not all of the effort would disappear if there were no vouchers, but the cost figures raise some sharp questions when viewed against voucher values. In one department, for instance, 61% of the vouchers in one shop area represented less than 50 cents of direct labor. We're paying more for vouchers than we are for work. It's illuminating to see what really goes on, what it costs, and why. Take requisition handling. The department in the example has 75,000 requisitions a year. 2/3 of the volume goes straight through order administration, and the cost per requisition is $8. But 10,000 requisitions a year go on to engineering, solely to have the catalog number identified, and the indirect cost jumps to $13 a requisition before they reach the shop. All because the order people are not in position to identify a catalog number themselves. Another 14,000 requisitions require design modifications and manufacturing instructions, and the cost jumps to $35 per requisition. Each year, 3,500 requisitions require new drawings. If we're talking 2 drawings, the price tag per requisition is now $162. The indirect effort and cost in this example becomes significant when we add the fact that 1 out of 4 of these requisitions has a sale-to-build value of less than $25. In a high-volume consumer business, the number of parts is a major determinant of indirect effort. If engineering can eliminate a single unique part, indirect cost savings will be $1,000 the first year and $300 a year for the rest of the model life. We presented 5 or 6 examples of the kind of questions that can be answered using this approach. There are dozens of other examples, such as the cost of introducing a new model or the cost of a line changeover in a high-volume business, or the use of standard parts or stock parts versus specials, or the trade-offs involved in pricing decisions. Such a list in itself indicates the need for insight into indirect costs. The approach we're describing is valuable in that it identifies areas where significant cost savings can be made and motivates people to find a better way. A host of ideas come out of looking at a business in this way. They all boil down to 3 specific opportunities for reducing indirect costs. First, the approach gives us the insight we need to help an individual make better decisions. Experience with this method has taught us that people are woefully ignorant of the effort their decisions create. This is not a lack of interest, but rather of time and lack of knowledge about a complex system. Undertaking a study provides cost indices to help people decide which actions will tend to cost more and which will cost less. That is, to evaluate the trade-offs. We have successfully educated people, 1,000 of them in the departments we've worked with so far. But education alone is not enough. We can use this information to establish better operating rules. Again, the gain comes from getting everyday decisions that go in the right direction. Decisions like those to make or buy, about stocking, design changes, parts, and so on. The second opportunity for reducing indirect cost is in simplifying specific practices, and goals can be set to accomplish this. For example, paperwork systems can be revised to eliminate practices that just don't make sense, like the dollar voucher, which initiates 50 cents of direct labor. And finally, the approach gives us insight into the value of an excellent tool for simplifying a business and lowering indirect costs, product structuring. In a moment, Frank McCune will discuss this final opportunity. Before we move on to it, however, we want to tell you how you can apply in your business the method that Phil and I have just discussed. Here's the program we're recommending. First, appoint a few cross-functional people to take this look. Your team should attend a 2-day seminar at which engineering, manufacturing, and accounting services will train them in the approach. There's a How to Do It manual which builds on the experience of departments already engaged in the program. The seminar will teach your team how to accomplish the work we've described. And finally, as your study progresses, services people will consult when they can be helpful. Gentlemen, that's our story. We've come to be enthusiastic about this opportunity to reduce indirect effort, and in this way, to get a stranglehold on indirect costs.
Just as value control holds promise for significant reductions in direct costs, this approach holds promise for lower indirect costs. The final presentation is about a new tool which can effectively lower both direct and indirect costs, product structuring. Here's Mr. F.K. McCune to discuss it. Frank?
Product structuring is a technique which recognizes the high cost of a single part, both the direct cost and the snowballing indirect cost which it creates. Ideally, if you were starting a business today, you'd start with a product line that has a minimum number of parts. And you'd have a minimum amount of paperwork for drawings, for planning, for ordering, costing, inspecting, and testing. Your development program would concentrate on the functional parts that you intended to keep on using. To do this means laying out your whole product line by models or types. It means laying these models and types out by their components, and then it means changing your product lines so the customer values are maintained, but the smallest practical number of components are used. It means planning the offerings for coming years, both with regard to customer wants and to the components which produce them. It means concentrating on the components that go on to future years and those that must be added, and dropping those components that don't go on for future years. It means ending with a factory that produces large quantities of relatively few parts and subassemblies which stay in production for a long time. It means that only the small end portions of the production line have to wrestle with variety as dictated by the customer. It means low overhead because of the few components to be made. It means low prime costs because components accumulate cost reduction ideas for many years. And finally, it means dependability because the components become reliable. The technique we call product structuring is simply a process to achieve that kind of operation with its many business benefits. It can be done, it works, but we know it isn't easy. Because product structuring is cross-functional. Engineering can't do it, manufacturing can't do it, marketing or accounting can't do it. The whole business has to do it, and everyone has to cooperate. But it can be done, and we know this because it has been done by the radio receiver department, for one. Their problem came in two parts. First, the market was calling for an increasing variety of radio models to meet competition at all levels: price, function, style, and features. And second, the Japanese invasion of the United States radio market had placed extreme pressure on all manufacturers to achieve lower and lower costs just to stay in business, let alone make a profit. Well, the radio receiver department did stay in business and is indeed profitable. According to General Manager Bob Wilson, one of the tools that proved extremely useful in making it happen was product structuring. And here is how it worked for them. These groupings represent high and low volume models. High volume radios are a family of tube-type clock and table sets at the left. The low volume radios are all kinds of transistor types. They include miniature clock sets, portables, and stereo FM units. Call them a standard and a special line. Product structuring was used on both lines. In the standard group are 10 different models. They total more than 1 million radios per year. Before product structuring, this group required 3 production lines to turn out 10 models. Now they're gearing up to produce 12 models on a single production line. Where there were 3 chassis for the 10 models, 1 chassis now serves 12 new models. It's the result of hard work by marketing, manufacturing, and engineering. And product quality will improve, since operators will continually build the same chassis. Cost savings will exceed $1 million a year, and further cost improvement should occur over the new chassis' long life. For the special line, this was a typical chassis, special for a single low-volume model. As a result of product structuring efforts, some building blocks were found, making possible a modular approach. This circuitry, for instance, performs an audio, an IF, and a converter function, common to all radios. A line of modules was designed to perform each of these functions. The modules run on relatively small, high-speed assembly lines. Since training time is very short, quality is greatly improved, and the modules can be tested before they are plugged into a motherboard to build up the special radio being produced. And so, product structuring helped solve problems in both the standard and the special lines. Another successful case history comes from a different kind of business, a tailor-made business, pad-type transformers. This is a line of small substations with 3-phase transformers, switches, circuit breakers, and so forth, all in one tank. A typical unit looks like this. They come in 16 primary voltage ratings, 6 kVA ratings, and 932,000 arrangements of components. That's right, 932,000, each with its own varieties and ratings. This was the fastest growing distribution transformer line. It was relatively unprofitable, and each combination was designed as the order came in. A product structuring approach showed that most of the variations could be incorporated into one particular part of the product, the front plate. This is the part to which are affixed all of the special bushings, ground pads, and switch handles which the customer calls out. Here's how production is now handled. For each transformer, the order is punched into data cards and then fed into a General Electric 304 computer. Stored in the computer is the information needed to develop the dimensions of the front plate. The computer output is punched into a paper tape. This operates a Weedomatic press which punches the holes. Eliminated are drafting, manufacturing, planning, and machine programming efforts. For the transformer cores and coils, as well as many other parts like bushings, tap changers, and switches, it was possible to shift from types which were low production items and therefore expensive. Substituting items in high production brought net costs down, even though the replacements actually do use more copper and steel than the original. Quality is improved. Here are some results. Any one of thousands of designs can be turned out by the computer in less than 6 minutes. Prime cost came down by $300,000 in 1 year, almost all in material savings, even though more copper and magnetic steel are used. Indirect costs are harder to pinpoint, but $235,000 a year is a fair guess. And in addition, shipment came down to 4 weeks. The customer still gets what he wants tailor-made for him. Now, there are more examples, but I'm sure you get the idea. Product structuring can't be applied in the same way and to the same degree across all our businesses from diamond dust to spacecraft. We know that. But if you have a line between these extremes, ask yourself, how many drawings do you have in your business? There were 1 million in power transformer. How many different parts do you carry in stock? How many of your product plans carry through to what components will be used in the future? And even more important, what components will be dropped? If your answers to questions like these sound like too many or not enough, then you should be investigating product structuring in depth. You should be prepared to take department action. It won't work function by function, but I can assure you that the payoff is well worth the effort.
Gentlemen, I think you'll agree that with our old approaches to labor and material, with the new value control approach Hal Miller has told you about to get even greater leverage on prime costs, with the study approach Phil Thibodeau and Charlie Fontaine described to gain insight into indirect costs, and with product structuring as it was described by Frank McCune, there is tremendous opportunity to reduce all costs. All we need is your willingness to put these tools to work.